Now, time is another very strange thing. In the quantum world, there's time indeterminacy. Between collapses, time goes neither forward nor backwards, but it's kind of smeared out. And there's some data that non-conscious processes can actually go backwards in time. And if we have time later, I'll discuss that because it's kind of interesting. So this is what a conscious moment would look like, or a series of them giving rise to consciousness with quantum information being able to go backwards. So the pre-conscious quantum superposition is under the curve, and then you have a series of conscious moments. Okay, well, let's say this is true. Why would it be conscious? What about the hard problem? Why do you smell a rose and hear an oboe, feel love or whatever? Well, a philosopher, this goes back to pan-protopsychism and merging with modern physics. Whitehead said that consciousness is a sequence of events or occasions occurring in a wider field of proto-conscious experience. A philosopher named Abner Shimoni made the comment that Whitehead's occasions are analogous, perhaps identical to quantum state reductions. Could quantum state reductions occur in the brain? Well, I think they can, by the mechanism I just showed you. But what about the wider field? Well, maybe it's the universe itself. Is proto-conscious experience an irreducible property of reality, like mass, spin, or charge? What is reality? What is empty space? What is this? Well, it's actually fundamental space-time geometry, which relates to quantum gravity. So what am I talking about? That's probably a very good question at this point. Well, what is thin air? What is actually empty space? This is kind of interesting. If you start with A, that's the size of a protein, a tubulin, if you will, and highlighted are the tryptophans. And then in B, we have an atom, 10 to the minus 8 centimeters. And let's say we're going to go down below the scale of atoms. And don't ask me how they know this, but physicists have looked at this. And as you go down and down in scale, everything is smooth until you finally reach a bottom level at what's called the Planck scale, where there's a pattern, there's information. It's 10 to the minus 33 centimeters. As John Wheeler said, it's kind of like looking at an airplane, looking from an airplane at the surface of the ocean. It looks very smooth. But if you were on the ocean in a boat, it'd be very choppy. There's information there. So the Planck scale is described by, you take your pick, string theory or quantum gravity or loop quantum gravity, spin networks, what have you. But the point is that there is information there. And it's non-local, it's interconnected all over the place. And Penrose said that this is where Platonic values reside. And then we came up, well, why not qualia? Maybe proto-conscious qualia are patterns embedded at this fundamental level. These quantum processes in the brain come along and access them and select them. Well, how would that happen? Well, Roger also addressed the issue that nobody else wanted to touch of what quantum superposition actually is. How can particles be in multiple locations or states simultaneously? And Einstein had said that mass equals curvature in space-time geometry. And Penrose and also the multiple worlds hypothesis said that superposition is a simultaneous curvature in alternate directions, a separation or a bubble in space-time geometry at the fundamental level. In the multiple worlds view, every superposition branches off to form a whole new universe. But Roger said, no, these separations are unstable, and after time will collapse and choose one or the other. So it would look something like this. A tubulin in one conformation would be curvature outward towards you, and in the other would be in towards the screen. And a quantum superposition would be a bubble or a separation in fundamental space-time geometry. So when it reaches this threshold, it's going to collapse and choose one or the other. So basically, we equated the tubulin qubit with a qubit in fundamental space-time geometry, and he had come up with this equation to predict when the collapse would occur. And we applied it to, I'm going to come to this in a second, we applied it to the brain, and for 40 milliseconds, it turned out basically roughly 1,000 to 10,000 neurons, the amount of tubulin in 1,000 to 10,000 neurons, the same number that Crick and Kolk had come up with. So, but the basic idea is that the qualia are actually fundamental patterns in space-time geometry. So the pattern in her brain, which represents red, is actually the actual redness, both in reality and in her brain, is a pattern in fundamental space-time geometry, shown by this cartoon, very simple cartoon version. Actually, it's much denser and more complicated. So to kind of wrap up, you think about the metaphors that we've had for a conscious mind over the thousands of years. The ancient Greeks said memory was a seal ring in wax. That's how memory was was formed. In the 19th century, we had minds as a telegraph switching circuit or the subconscious mind boiling over like a steam engine. In the 20th century, we had conscious mind as a hologram, classical computer. And I'll predict that in the 21st century, we'll be thinking of consciousness as a quantum gravity computer. And this is the conference that John mentioned, Quantum Mind 2003. Penrose will be here, a lot of other people. It's free to U of A people. It's during spring break, although it doesn't apply to those of us who work at the medical center. Here's the website, and you're all welcome to come. And I'll just close there. Thank you very much.
Have any quantum effects been observed at the neuronal level, say, neurotransmissions between, say, synapses across neurons?
Well, you got to be careful because we have this quantum of neurotransmitter vesicle. But ignoring that, Beck and Eccles experimentally proven no. Well, everything at root is a quantum level, but the idea is most people say it gets washed out above a certain level by decoherence. And people scoff at our ideas because they say to build quantum computers, they have to be built at absolute zero to avoid thermal vibration. So how can you have these quantum effects at the warm brain? And the answer, I think, is that evolution is at 4 billion years to solve the problem. And if you go to my website, there's this whole argument about decoherence. And a physicist named Max Tegmark wrote an article about this, claiming that it was impossible that the microtubules would decohere in 10 to the minus 13 seconds. And science picked this up and kind of trumpeted the death of the quantum mind idea. Well, some physicist colleagues and I wrote an article which was published in the same journal, PhysRevue, that Tegmark published, showing that given the constraints of our model, he actually invented his own microtubule quantum model and shot that down. But using the constraints we had specified, that the decoherence time is in the order of hundreds of milliseconds within the range that we needed. As far as experimental proof, no, not yet, but we have testable predictions. And there's several on my website in the appendix of the paper, appendix of the paper in the Philosophical Transactions of the Royal Society is a list of 20 testable predictions. And that's exactly what I'm going to be talking about at the Quantum Mind Conference, is testable predictions. Roger's going to talk about testable predictions of the objective reduction side. I'm going to talk about the biological side. Richard.
Very nice.
Thank you.
With those testable hypotheses, I'm just wondering, is the quantum theory of consciousness falsifiable? And if so, how would it be falsified?
It's far more falsifiable than any other theory. How would it be falsified? Well, if you could produce consciousness in a purely classical system, the problem there is how do you prove it's conscious, which is a problem for everybody. That's true. I should say that almost all drug receptor interactions are basically a quantum effect at that level. But that's not the same as macroscopic quantum coherence, which is really what I'm saying. So if someone could, if you could produce consciousness with the cytoskeleton inactivated, assuming it's not quantum effects at the membrane, that would invalidate our theory, for example, because we're presuming it's quantum effects in the cytoskeleton. But as far as the emergence theories are not falsifiable, as far as I can tell. I'd say ours is.
In the context of your theory of consciousness, how do you use states like psychosis and dissociation? Is that useful to consider?
Well, if you go back to the slide about the altered states, the idea there is, for whatever reason, you don't return to baseline, so you're merging what's normally in the subconscious with what would normally be conscious. So if you think of all the bizarre things in our dreams and whatnot, if that becomes part of our everyday moment-to-moment life, that could qualify as psychosis. And I also might add that there's some interesting data from the 1970s on hallucinogenic drugs by Kang and Green and Saul Snyder when he was a young guy, who showed that they did something called electron resonance orbital energy, and they showed that they had an analogous series of psychedelic hallucinogens. They found that the potency was proportional to the energy donated to the receptor, suggesting that that the receptor and everything connected to it would be more likely to go into a quantum state. So I think, I take that as some support for the idea that hallucinogens promote a quantum superposition phase.
Do you see any interplay between quantum theory of consciousness and emergence? For example, qubits serving as fractals or embedded as an embedded structure?
Well, the collapse itself can be looked at as an emergent phenomenon. I mean, what's emerging is a classical state out of a quantum state. So it's a type of emergence for sure. And also, I think higher levels of consciousness are emergent phenomena. As far as fractals, there's actually going to be an interesting talk at the Quantum Mind Conference about a fractal theory of mind. But it's kind of like and of course, Carl Pribram's also going to be at the conference. He's been talking about a holographic theory, which is basically the same thing. Structurally, the cytoskeletal network within each neuron is kind of like a fractal subdimension of a neural network for us within a tree. So this gives a lot of opportunity for fractal analogies, at least. And there's one guy, Erhard Bieberich, who has a serious fractal model of mind with mathematics and everything.
Have you or others looked into the amount of information stored in brain states? It sounds like your prediction is that the brain can have more possible states.
Right. Yeah, I actually had a slide. I didn't show it. Classically, 10 to the 11th neurons switching, in milliseconds, 10,000 synapses gives you about a maximum of 10 to the 15th states per second, which is a lot. And AI people, but we have computers that almost do that, and they're not conscious as far as we can tell. If you say that fundamental switching is occurring at the tubulin level, they switch faster in the nanosecond. There's roughly 10 to the 7th tubulins per neuron switching in the nanosecond region, so that's 10 to the 16th. So you go from 10 to the 15th, you get up into the 10 to the high 20s, basically. But more importantly, you get this quantum superposition with this massive parallelism. So as far as brute force, and by the way, if you just go back to the classical phase, when I first started talking about this in the 1980s, the AI people did not like me whatsoever because it showed that the goal line, if you will, for building a computer that would equal the brain, I'd push the goal line another 20 years. But even if that were true, that doesn't explain consciousness. I think you need some kind of, something funny like this quantum gravity mechanism to explain the hard problem.
Website again? I missed it.
It's the same as this, except instead of Quantum Mind 2, just put my last name, Hameroff. Hameroff. Thank you.